Alright, well, welcome to our first episode on linear functions. And so to get us started, we're going to right away dive into what is considered our parent function for linear functions. Alright, so one thing to keep in mind is the word linear means a line. So when we learn our parent function, it should be in a form of a line. Alright, well, to get started here, very quickly, you'll notice all we're going to do is we take our x values, -2, and we're going to plug it in into our parent function equation x. Well, you notice it's just x. So if I plug in -2, I'm just going to get -2, right? It's just replace it with that number. If I take -1 and put it in, I'm just going to get -1, well, 0, 1, 2, okay? Again, this right here is my parent function, y is equal to x, okay? It's always the original equation, right? You'll notice that we're not adding anything to the outside, we're not multiplying anything, it's just x. And you notice whenever we study a parent function, it's always going to be just that equation itself with no other numbers added to it. So let's go ahead and graph this guy. So at 0, 0, it's 0, 0. Again, another key feature is that we'll always pass through the origin, which is right here, right through the middle of the x and y axis. So I'll just go ahead and graph a few couple points here. All right, there we go. Looks pretty nice. That's nice. All right, so this is my parent function, y is equal to x. And you'll see it's just a line. It's just a straight line like this, and we know it's y equals x, and that's all we have to do. All right, now let's go ahead and begin to understand what happens, okay? Maybe a scenario where we have a new equation, all right, which is y is equal to x plus 3. All right, now you'll notice, okay, now we are adding some number, right? And now we might ask ourselves, well, what exactly is happening? What are we doing to our function? And it's so important to learn graphically anytime you see an equation, what are these numbers doing to the graph? And I think that's a key thing that a lot of times isn't covered. So I'll put the same x values, okay? All right, now we have to plug in, well, just kind of like what we talked about before. We're going to take -2 and we're going to plug it in for the x variable. So we plug it in, I'll do it right here, -2 plus 3. I'm just taking the -2 and replacing it for the x, which is right here. All right, and we get +1. So I'll go ahead and write +1 there. All right, let me just get rid of that work, and we get +1. Okay, well, now I'll take -1 and plug it in. Well, I'll just actually just do the work here. -1 plus 3 is +2. All right, I take 0 and I plug it in for x, and I'll do 0 plus 3, and that's going to give me 3. 1 for x, and we're going to get 1 plus 3, which is 4, and obviously we're going to get 5 down here. You can verify them, all right? So, well, first thing I want you to do is, what do you notice? All right, what do you notice the connection between these y values from our parent function to these y values? See, the x values we kept the same, but what happened to our y values? Well, look over here at 0, 0, it now became 0, 3. At 1, 1, it now became 1, 4. And at 2, 2, it now became 2, 5. Well, do you notice a pattern? There we go, right? All we're essentially doing is this plus 3 is adding 3 to the y value. So we're just adding 3 to the y values. That's what this plus 3 does. 0 plus 3 gives me the 3. 1 plus 3 gives me the 4. And the 2 plus 3 gives me the 5. Okay? Well, what does that mean on the graph? Well, that means that if we actually go and graph it, we're taking our parent function, this pink line, and we're shifting every y value 3 units up. So 0, 3, we'll put it right there, 0, 3, 1, 4, 2, 5, right? And I'll just go ahead and plot these down over here. Okay, oops, not the straightest line, I do apologize, but we get something like that here. And what do you notice? Well, we just took our parent function and all we did was just grab this and just moved it up 3 units, right? And that's where the plus 3 comes from. So you'll notice if I start at this point, I just go up 3 times, 1, 2, 3, and you see it clearly maps it right onto there, 1, 2, 3. 1, 2, 3, 1, 2, 3, and it clearly maps up there. And so that's basically what the plus 3 is doing. It's just shifting our parent function equation up by 3 on the y values. All right, pretty cool, huh? Well, let's go ahead and maybe look at one more example, right? And let's go ahead and do, well, what about if we had y is equal to x minus 4? Okay, something like that. Well, you know what? Actually, let's change it. Let's do y is equal to x minus, okay, we'll stick with it, x minus 4. All right, well, let's go ahead and make a little table. Okay, I'll go ahead and just choose kind of these basic numbers that we kind of had. Okay, one thing I want to do is I'll go ahead and draw my parent function, right? Because we're going to want to compare it always to our parent function and see what kind of transformation happened. Okay, well, we got this graph right here. This is my y equals x equation. Okay, well, over here, let's go ahead and begin plugging in some values. All right, plug in -2 into here, and we're going to get, I'll just do the work over here. -2 minus 4. Well, -2 minus 4 gives me -6. Okay, -1 minus 4 is going to give me -5. 0 minus 4 is going to give me -4. 1 minus 4 is going to give me -3. And 2 minus 4 is going to give me -2. So let's go ahead and graph it. Right, 0, it's -4. And you can see at 1, it's -3. 2, it's -2. And then we'll go ahead and graph it down here. Okay. Well, what do you notice happened to our green line to our new equation? Well, you'll notice all we did is just move this green line down by 4 units. We just shifted downward. All right. Similarly, when it was a +3, all we did was move it up. Well, when it's a minus, you just move it down. So you could just imagine that if I have something like, let's say y equals x plus 100, right, how will that look like? Well, here is my parent function. Oops, it should cross to the origin. I do apologize. Well, plus 100 means you're just going to go up 100 and just shift it up. And that's how it should look like, right? Well, what if I had y is equal to x minus 271? Just some random number. Again, draw our parent function. Okay, our parent function goes through the origin. Well, it's minus, we're taking this line and we're going to shift it all the way down. Let's say down over here, -271. And it's going to look like that. Okay, so you notice these numbers that we add or subtract, they do in fact they just change our y values. You're shifting it up or down. Hopefully that helps you to understand a little bit of how this works with linear functions.